Helium has 2 electrons. So if you look at the orbital notation, we go in the same order. The first energy level you come to is 1. The first sublevel is S, and then the S sublevel has 1 orbital. So if we count to helium, you count 1, 2. So there are your 2 electrons. That's the orbital notation for helium. Electron configurations, that's the shorthand of the orbital notation. So if we were going to write the electron configuration for helium, it would be 1, S, and then the number that we write here at the top as a superscript is 2. So the 1 represents the energy level, the S represents the sublevel, the superscript 2 lets us know that we have 2 electrons. Let's look at another example. Let's look at lithium. If we write the orbital notation for lithium that has 3 electrons, we start off with the first energy level, the S sublevel, the first orbital. So we count 1, 2. They're your first 2 electrons. After 1s, you come down to the second energy level, the first sublevel. The S sublevel has 1 orbital. Well, when we count 1 space, and that's lithium, so that's our third electron. So lithium has 3 electrons, and here are our 3 electrons. If you're going to write the electron configuration for the lithium, and again, the electron configuration is a shorthand, we would write 1s for the first energy level, the S sublevel, the 2 electrons. We would then write 2s for the second energy level, the S sublevel, and then the number 1 for the 1 electron. Now, where before 1s were understood, we now have to write the 1s as superscripts. Let's look at another example. All right, so let's take a look at another example. Let's look at nitrogen. And this time I'm not going to draw out the orbital notation. I'm simply going to write the electron configuration. So we start in the first period, which is 1. We still have to count 1, 2. So we have our S sublevel and 2 electrons. Now that we're done with the first energy level, we now have the second energy level, the S sublevel. So we're going over here to nitrogen. So we have to count 1, 2. So those are 2 electrons, the superscript 2. Now that we're done with 2s, we come over here to the P sublevel, which is still in the second period. So now we have 2p. But we no longer have to draw out all 3 orbitals. We can simply write 2p. And if we count to nitrogen, we count 1, 2, 3. And that is the superscript that we write for our electrons. So if you count, 2 plus 2 is 4, 4 plus 3 is 7, and that's how many electrons nitrogen has. Let's look at sodium. Sodium has 11 electrons. So we always start with the lowest energy level, which is 1. We come to the S sublevel, and we count 1, 2. Now we're down to the second energy level. The first sublevel is S, and we count 2 electrons, 1, 2. Now that we're done with 2s, we come across to 2p, and in the p sublevel we have a total of 6 electrons. 1, 2, 3, 4, 5, 6. So now we go over here, 2p, and we write the superscript 6 to represent those 6 electrons. Now that we're down at the end of the second period, we move to the third period. The first sublevel we come to is S, and sodium is our first electron in this one, so we only count 1 time. So let's add up. We should have 11 as our total when we get the sum of these superscripts. 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 1 is 11. So let's pay attention to a couple things. Nitrogen is in the second period. The highest principal quantum number you have here is 2. Sodium is in the third period, and the highest principal quantum number you have here, is 3. Let's look at another example. Let's look at chlorine. So the highest principal quantum number we should write is 3 because chlorine is in the third period. So we have 1s, 2, here, that's our 2, second energy level, S sublevel, and 2 electrons, 2s2. We come across to 2p right here, and that's 6, 1, 2, 3, 4, 5, 6. Let me erase that stray mark. All right, after 2p6, we come down to 3s, 2 electrons. We count 1, 2. After 3s, we go over to 3p. And if you count with me for 3p, that's 1, 2, 3, 4, 5. And that is going to be our superscript. All right? So now we're going to look at D sublevel elements. So with our D block, now we're going to do an N-1. So here's a new rule that's being introduced. So whenever you have an electron configuration for a D block element, you're going to take this principal quantum number and subtract 1 from it. Same thing we did before. So we have 29 electrons that we have to draw. So you start with the lowest energy level, which is 1, the S sublevel, and 2 electrons. Here you 2, 1, 2. You now go down to the second energy level, the S sublevel, and we count 1, 2. We then go to still the second energy level, but now we are at P, 1, 2, 3, 4, 5, 6, 2p6. After the P sublevel, we're at the end. We now go down to the third energy level, the S sublevel, and 2, 1, 2. After we leave 3s, we move across to 3p, and that's going to be 1, 2, 3, 4, 5, 6. So that gives us 3p6. After 3p6, we move down to the fourth energy level, which is 4, the S sublevel, and then 2, because we have 1, 2. And then as I stated, we have N-1. So 4 minus 1 equals 3. So now we have 3D. And now we're going to count over to copper. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that becomes a 3D 9. And that is our electron configuration for copper. Now, one of the things that you need to make sure that you do as your final answer when you have to write these electron configurations is to make sure that you put them in order by principal quantum number. Remembering that the principal quantum number, that's that number at the front that represents the main energy level. So in order for you to get credit, it must be written as 1s2, 2s2, 2p6, 3s2, 3p6, and now after I have my 3p6, again, it's going to be written in order by principal quantum number. That becomes 3d9, and then 4s2, all right? That is the correct electron configuration, because when we look at this, we see copper is in the fourth period. And so the final energy level that you write should coincide with the period that the element is in. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, and 4s2. All right, so let's take a look at another one. Let's take a look at arsenic. Arsenic is number 33, has 33 electrons. So if we take a look at arsenic, we start with the lowest energy level, which is 1, the S sublevel, 2, the second energy level, S sublevel, 2. We come across to the 2p sublevel, and if you count, you have 6. Now remember, we've got to go all the way down to arsenic. So after 2p6, you come down to the next energy level, which is 3, the S sublevel, 2 electrons. We move across from 3s2 to 3p6. After 3p6, we have 4s2. After 4s2, remember n-1, so 3d. Remember, we have to get all the way to arsenic, so it's going to be 3d10. And then after 3d10, we're back to the fourth period, which becomes 4p because this p sublevel is in the fourth period. So it's 4p. And now count to arsenic, 1, 2, 3, 4p3. Right? Now, again, remember, it is just the D sublevel that is n-1. So after we leave the D sublevel, we're back in the fourth period. If you move across, you'll see that this arsenic is in the fourth period. So now we have 4p, 1, 2, 3. So it becomes 4p3. Now remember what I told you just a few moments ago. You have to write them order by principal quantum number. So this 3D should fall here so that you would have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, and 4p3. So I'm going to rewrite that for you. All right, so the correct way to write this would be 3d10, 4s2, and 4p3. Let's take a look at rubidium. Rubidium's electron configuration with 37 electrons. So this time I'm going to write it all the way out, but I'm going to write it in order. So I'm not going to rewrite it for you. So remember that this is going to be 3D because it's That's going to be 3D because it's n-1. This is going to be 4D because 5 minus 4 is 1. And this will be 5. But we won't go past barium, so you should be good. So the farthest we'll go with our electron configurations would be barium. So let's take a look at rubidium. We have 1s2, 2s2, 2p6, 3s2, 3p6. Now, I've got 3p6. Now I'm in the D sublevel, so I know I have to do 4s. I have to go through 3D, so let's go ahead and write 3d10. 4s2 because we're going to write it in order of principal quantum number. 4s2, this is going to be 4p6. And then the last one that you will write for rubidium is going to be 5s1. All right? So if you have any questions, bring those questions to class with you and watch this video as many times as you need as you practice and learn the content.